It looks like so far here everything is good to go. Again, we're going to keep practicing. Let's look at letter C, carbon and oxygen. So we're only going to do one of each is what we're looking at. One carbon and one oxygen. Well, what's my step number one? Is I'm going to come to the periodic table. Remember, go find what group they are so I can see the number of valence electrons I'm working with. Carbon is in group 4. Oxygen is in group 6 or 16, so there should be 6 here. So a total of 10 valence electrons is what I'm working with. Okay, so I have 1C10, 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 1C10. So all three of those are good. Now, remember, everybody has to have a total of 8 valence electrons for themselves. Okay? All right. Let's start over here. Let me cover up the oxygen and let's look at the carbon. Let's count them up. 2, 4, 6, 8. That looks good. Let's go ahead and cover up the carbon. Let's look at the oxygen. 2, 4, 6, 8. That looks good too, right? Let's keep going. Let's look at this one. 2, 4, 6, 8. Let's look at this one. 2, 4, 6, 8. That looks kind of good too. Let's keep going. This line is 2, 4, 6, 8. That's looking at the carbon. Let's look at the oxygen. 2, 4, 6, 8. Ooh, kind of weird, huh? They all so far, I haven't been able to like scratch somebody out right away. Okay. Let's keep going. Now, we have to have a total of 10 valence electrons in total, if that makes sense, right? Now that we did all of our, lines here, this is only a single bond. Let me go ahead and cover up one of those 2's. How many, and when I add them all up, they should equal 10. Let's look at this. 2, 4, 6, 8, 10, 12. Whoa. 2, 4, 6, 8, 10, 12, 14. Whoa. 2, 4, 6, 8, 10. That looks good. Too many valence electrons. Too many valence electrons. And our correct answer is over here. Did you see hopefully how I got the right answer? Again, I added them all up. I made sure I have the correct number of atoms, which I did. And then I looked individually at each atom to make sure that they were 8 and they were okay. But then total, with all of them bonded together, the max I can have was 10. And I had 12, 14, and this one was 10. So that's the reason why this is the correct molecular drawing here for our compounds. Let's look at letter D. All right, letter D. I've got B and 3 F's. So let's go ahead and write that down. B, F, F, and F. So let's look. 1B, 3 F's. 1B, 3 F's. 1B, 3 F's. So far, they're all okay. All right. The next step is we go to our periodic table and we look. B is in group 3, so 3 valence electrons. Fluorine is in group 7, so that's going to be 7 valence electrons. Let's add them all up to see what the total number is going to be, because we need to make sure that we reach that total number. 5, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 valence electrons is the magic number that we're working with. Okay? And that is overall total. Alrighty? Now, let's go ahead and let's look. How do I know that B is the correct central atom? Now, I understand they all have B as the central atom here. But remember, between B and F, B is further to the left on the periodic table than F is. So that's the reason why B, boron, is going to be the central atom, the Ca. And the fluorines are what we call the terminal atoms. Now, let's go ahead and I'm just going to count them all up. I'm going to put 2 here. Those are 2, 2, 2, 2, 2, 2, 2, 2, 2. Each line represents 2 electrons, right? 2, 2. And I'm just going to put just 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, and 2. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, and 2, and 2. There we go. Now, one of the easiest way is really just to go ahead and count them all up and make sure that we reach that 24 number, okay? So that's really one of the easiest way. And then we also need to make sure that each element, remember one more time, each element has a total of 8 except, oh, look at this exception, except for the boron. And I'm going to put just a little B here in parentheses. And my boron needs to have how many? 6, not 8. So let's check that out first, because that'll probably be an easy way to knock somebody out of the way. Boron. This line is 2. This line is 4, 6, 8. Can boron have 8 valence electrons? No. Right? Boron can only have, how many is it? 6 valence electrons, not 8. Okay, let's keep going. Let's look at this one, because this one has 2 dots here and this one doesn't. This line means 2. We wrote it out. This line means 2. That's 4. This line means 2. That's 2, 4, 6. Plus those 2 right here that are attached to the boron means 8. No, that's not going to work, because boron can only have 6 valence electrons, not 8. Let's double check to make sure this one is correct though. Boron has 2, 4, 6. That works out. Plus, now that we did those 6, let's count everything else, because we got to get to 24. 6, 8, 10, 12, 14, 16, 18, 22, 23, 24. This is our correct answer. Boron has 6 valence electrons, which is correct. And total between all 4 of them bonding together, I have to have 24, and 24 are shown, so we're good to go. Let's look at the next one over here. The next one has hydrogens, 2 hydrogens, H2O, and oxygen. Okay, 2 hydrogens, oxygen, 2 hydrogens. So they're all the same amount of electrons, atoms, I'm sorry. They have the same amount of atoms, or the correct amount, which is good. Now, hydrogen is in group 1. So 1, 1. And oxygen is in group 16, or 6. So let's go ahead and write that down, 6. So 6, 7, 8. What's my total number? My total number needs to be 8 for everything, okay? Oxygen is going to be my central atom here. Hydrogen, it says in our rules up here, is that hydrogens always have to be terminal atoms. They can never be central. So that works out. All right, let's keep looking. The other thing, though, is that oxygen has to have a total of 8 valence electrons, and hydrogen can only have a total of how many? 2 is what it says. So if you look at this, we can already knock this one out. Look at all those elements, Look at all of those valence electrons on hydrogen. Hydrogen is not that big to be able to hold and withstand that many valence electrons. So I'm going to go ahead and put right here too many valence electrons on the hydrogen. Okay? Now, if we look over here too, this one has 2 and this one has 2. That means that this one hydrogen has 4. And this hydrogen has 2, and this one has 2. So it has 4 also. Again, too many valence electrons on the hydrogen atom. Let's double check to make sure this is correct. This hydrogen has 2, so that's good. This hydrogen has 2, so that's good. And here are 2 electrons and 2 electrons. How many does the oxygen have to have? 8. Let's look. This line means 2, 4, 6, 8. How many total valence electrons do I need? The magic number is 8. I come over here and I have 2, 4, 6, 8. Bam. There we go. That's the right way to draw the molecular drawing here, and that's the reason why. Hopefully this helped out. Again, I know it's a little off and a little weird, something new that you probably have never done before. I promise you, with practice, it will become a little easier. Make sure that you follow the rules, though, when it comes to the drawings, okay? And molecular shapes is our next topic. So we have, yep, we'll keep going. So molecular shapes. So we call this the VSEPR model, and the reason why we call these VSEPR models is that the VSEPR stands for valence shell electron pair repulsion theory. I know, huh? A lot to take in. Now this model is based on the arrangement that minimizes the repulsion of shared and unshared pairs of electrons around the central atom. Lone pairs are not shared between two nuclei and occupy a slightly larger orbital space than shared electrons, okay? And I know this right now kind of sounds like a crazy hot mess, but give it a little bit of time and it'll start to make sense, okay? Now there's a few things that we need to do here. First one here is I need to come over here and I see fluorine and I see iodine. And what we're going to do is we're going to do the Lewis dot structure for them. So let's do fluorine. And here's iodine. And let me zoom in a little bit. Hopefully that helps. Now go to the periodic table. I see that fluorine's in group 17. So 1, 2, 3, 4, 5, 6, 7. Iodine is in group 17 also. 1, 2, 3, 4, 5, 6, 7. What's going to happen? These are two nonmetals that are bonding together. They are going to share. When they share, we have a line. The line represents sharing. Okay? So now they're going to share right here. The number of atoms bonded to the central atom. This is the central atom. Or is this one the central atom? Do we know which one? Well, when I look at them, if we look, this can be the central atom, this can be the central atom. There's only two of them. So how many atoms are bonded to the central atom? If we call him the central atom, he only has fluorine. If fluorine's the central atom, he only has iodine. So 1 is the answer. The number of lone pair electrons on the central atom. Now, who is my central atom? If you're not sure yet, let me tell you that it's going to be fluorine. Okay? How do you know, Miss Munson? Because fluorine and iodine are both in group 7. That is true. Fluorine is higher up on the periodic table. It's the first one in the group. He's going to be the central atom. So how many of what we called lone pair of electrons on the Ca? What are lone pairs? Lone pairs are not shared between them. Lone pairs are not shared. So if fluorine is my central atom and the lone pairs are not shared, this is a pair of electrons that are not shared. This is a pair of electrons that are not shared, and that is a pair of electrons that are not shared. So how many pairs? There are 3 pairs of electrons that are not shared. The shape that we call this is linear. Okay? And the polarity, whether it's polar or non-polar, is what we're going to get to in a little bit on the next page, but we'll come back to that later on, okay? And let's go ahead and while you're here, write in another column. We're going to call this bond angle. We're going to make another column here, and the bond angle for this linear bond is going to be 180 degrees. And if you look at it, this is 180 degrees. All right. Let's go ahead and let's keep going. Again, I know this is really weird, okay? But nitrogen, I should have probably did that over here and I didn't. Let's go ahead and practice, and let's continue to do our practice like we did on the page previously. 1 nitrogen, 2 nitrogens, because there's N2. Nitrogen is a diatomic, so it has to be bonded to himself. Nitrogen's in group 5, so 5 valence electrons, 5 valence electrons, which equals a total of 10. So when they bond together, okay, nitrogen is going to form 10 valence electrons around them. 2, 4, 6, 7, 8, 9, 10. So a total of 10 electrons, and here they are. 2, 4, 6, 8, 10. And let's look at nitrogen just by himself. 2, 4, 6, 8. Check. 2, 4, 6, 8. Check. So all of that matches up. Okay. Number of atoms bonded here with the central atom. Well, I mean, how many atoms here are bonded with the central atom? I mean, that's an N and that's an N. You know, they're both, I mean, can be considered the central atom. Same kind of weirdness over here. But only 1. Number of lone pairs is, well, let's look. Lone pairs, 1. All right. Shape, linear. It's linear. It's linear. We'll come back to polarity. And what is the bond angle? 180 degrees. Again, I know this is weird. It will make more sense soon. Let's look. Silicon with 2 oxygens. So silicon, oxygen, oxygen. So silicon is in group 14. Oxygen's in group 16. Add them all together, 5, 10, 15, 16 total. Now I need to bond them, okay? And then if I've got 1 silicon and I got 2 oxygens, who's going to be my central atom? Probably the silicon, okay? But again, if you look on the periodic table, silicon is further to the left than oxygen, so he is my central atom. All right, so silicon here. And what do we need to do? We need to make sure that when we do our bonding, we want them to be as symmetrical as possible. The more symmetrical our bond is, the less energy that those atoms are going to need to make and form the bond. Okay, and remember, atoms are just like regular human beings. We can be pretty lazy and we want to use them the least amount of energy possible. Same thing when it comes to bonding. They want to use the least amount of energy. So how can I make this symmetrical? Well, why don't I put an oxygen over here and an oxygen over here? That would be pretty symmetrical. Okay, now how many atoms? I need 16 total, and each atom needs to have a total of 8 for themselves. Okay, but 16 total. So in that case, it sounds like we're going to have to do some sharing, if that makes sense. And how do we represent sharing? With lines. Okay, so let's look. Why don't we start off with just 2? Okay, and if we do that, 2, 4, 2, 4. Because each line represents how many? 2. So let's look at silicon. Since it's the central atom, cover up the oxygens. 2, 4, 6, 8. Bam, silicon's already done. He's happy, he's content. But is oxygen content? He only has 2, 4, 5, 6, 7, 8. He looks happy. 2, 4, 5, 6, 7, 8. Now he looks happy. But what's the overall thing? We cannot reach more than 16. So let's count them all together. We got 2, 4, 6, 8, 10, 12, 14, 16. Bam, we got it. That is exactly how we're going to do the molecular drawing. The number of atoms bonded to the central atom. Oh my goodness, we're still back on this part. Only 1, okay? Oh, I'm so sorry, 2. if Si is my central atom, then it has two terminal atoms, right? One here, one here. Let's look the number of lone pair of electrons on the central atom. This central atom has no lone pairs. They're shared, but no lone by themselves. What kind of shape is this? Well, I can see that this is also linear, right? It looks like a line, linear, and it's also 180 degrees, okay? They're not all linears, okay? And then we have B, boron with hydrogen. We have carbon with chlorine, and we're going to keep going. So we're going to practice all of them and do them all before we get done. I'm not going to leave any of them for you to do on your own because they are going to take some practice. Alrighty, so go ahead and finish these notes. Let's finish these notes up. I think it's going to be helpful to maybe watch them and write them down before we talk about them in class. Alrighty?